Hello, I'm Cheuk, and welcome to listening to my talk. So I'm going to talk about pandas. Me personally, I have a love-hate relationship with pandas. So I hope this talk will resonate with some of you. If you are struggling with pandas, I hope that some tips that I give in this talk will help you. So here's my contact information. You're very welcome to follow me on Twitter if you want to. So I would like you to spend a few seconds to think about what is your pet peeve about pandas. If you use pandas every day, I'm sure you will have moments that you really found pandas annoying and difficult to use. Yeah, that's normal. So before I tell you my pet peeve, I would like to introduce myself. I'm Cheuk, and I love open source project. I've been involved in different open source projects in the past. I also organize events, so you may be able to meet me in person in some other conferences. And also, I love talking about things, so I stream on Twitch during the pandemic. Nowadays, I would rather go to conference and meet all of you. So my number one pet peeve is that, you can't put your dataset in pandas, because pandas store, dataset in memory. And, unless you have a super gigantic big RAM, I think you won't be able to put a huge dataset in pandas. So what should I do? Well, first of all, you have to understand that pandas is not designed to handle a lot of data. But if your data is reasonably large, you may be able to just squish it and shove it into a pandas data frame if you try this trick. The D-type option. So, when you read a CSV, you can use a D-type option to specify which column, what the type of that column, or what data type of that column would be. So for example, here, I have a data set, I have a movie ID, and I know it's going to be a bunch of numbers, and they are not too big. So an int 32 is probably be enough to store it. So I have other things as well, they're string, that's fine. Because not all numbers actually are that huge or need that precision to be stored in a float 64 or an int 64. So by cutting it down to maybe using half of the memory to store the same integer, you can actually save some space. You can just maybe shrink down your data frame into a size that could fit in your memory, or reasonably small that you could handle it in memory. So also the bonus is that there's no more guessing. I think we all have this experience. We try to read a CSV. One of the column is supposed to be integer. But then everything seems fine until you try to do some operation on it and realize that that column is a float. Why? Well, maybe you have a missing data in there, and because NaN is a float, that's why the whole column become a float. If you use D-type and specify that it should be an integer early on when you read the data frame, then you may be able to spot this problem early on and handle it separately. Also, this way of doing things is not just save memory, it also makes the operation more efficient because it uses less memory. There's less, operation, especially to handle all these memory things. So it would actually be more efficient. And so I really recommend, if you have never done that before, try doing it. Actually do it every time if you know the type of the columns of the CSV. Another way of trying to handle a huge data frame is that do it in chunk. Not all of the processing need to handle the whole data set in one go. So if you can process the data in chunk, process it in chunk. So if you use the chunk size option in read CSV, actually it will create an iterator that you can iterate through and process chunk by chunk. Usually in this scenario, I would like to use it together with another library called TQDM, which will give you a progress bar when you process it. So it's actually nicer. You can just like look at the progress instead of staring at a frozen screen that wonder when is it finished. So that's a bonus. It's very useful, especially when you are not, directly putting all the data into a model. Some of the model, of course, you can train it chunk by chunk, but a lot of times you may want to store this process data somewhere for future use. Then it's very useful. It would actually be faster than doing everything all at once as well. So the second pet peeve I have is Pandas could be very clumsy to use and also very confusing at times. What do I mean? Have you ever noticed that there are multiple ways of doing things in Pandas? For example, if you want to get a column, you will see examples of using the dot operator, just like getting an attribute. Or you can, do it like a dictionary, use the square bracket and the column name. So, why? And another example is you can, for example, for sum, mean, and max, or average, you can actually use the Python built-in sum to do it, or you can use the Pandas method .sum to do it. Which way is better? Sometimes, the Pandas method itself, there are aliases. There are two methods that have different names but do the same thing. So, which one should I use? I would say that for my personal preference in this example, the first one, getting a column, I would use the dictionary way of doing it because, well, what if your column name has a space in it? Then the first method won't work. So just to be, fail-proof, I would always do it the second way. Also, for the sum method, I would actually use the Pandas method because actually it's much faster. Pandas, the method that Pandas provide actually is optimized to handle Pandas data frame. It uses some C extension or this trick to make it faster. The generic one, the Python built-in one, actually it's just designed to handle any iterator, so it's not optimized for a Pandas data frame. So I would use the second one for performance. The last example, I usually choose these aliases by popularity. So I think recently I see more is NA than is now. So I would just try to stick to the more popular one because if there's more example of using that method out there, probably people who are reading your code will understand that more than the least popular ones. So for readability reason, I'll just try to stick to what I think is more popular. So that's the way of dealing with the very complicated nature of Pandas. Another thing that Pandas is very complicated is the multi-index. Maybe you have already seen it if you have done a group by, an aggregation or a pivot table. You will end up with a data frame that has a multi-index, which I would say is not the best thing of the world. It's very complicated. So the easiest way is to just do a reset index after these operations, and you will get a normal data frame back. The last thing is, do you know that you can use a SQL query on a Pandas data frame? If you are someone who is very fluent with a SQL query, you can just use .query on a Pandas data frame and put in your query there. You get the result as if the Pandas data frame is in the relational database. So that's something that you could try if you are familiar with SQL. So number 3 of my pet peeve is that it's very confusing. There's series and data frame. What are they? So, for example, you have this, right? I have given you this example before. You'll get back a column which is a series object. But if you try using a double square bracket, you will get a data frame with only one column in it. In context, they are the same, but why are they two different objects? Well, series is a 1D labeled array. Think of it as a list, but it needs to be holding the same data type of things. Data frame is a 2D structure, so you can think of it as list of a list. Even though this list could only have one list in it, which is our example on the right-hand side there. So, but it's a total different structure. So that's why we have series and data frames. And data frames, you can think of it as consist of multiple columns, and each one of them can have a different data type, storing different things. So there you go. So be careful. Even though series and data frame, a lot of operations, they can be applied to both. For example, sum, min, max, those can apply to both, but they're different type of objects. So once you understand that, you'll find that it's actually not too difficult to distinguish the two. For example, the example on the right-hand side, because the list that consists of the column name user can have multiple column names, can have user and then maybe age, then, that would give you a data frame. So that's why, that one gives you a data frame. This is just a special case of having only one column in it. So, to conclude, Pandas is still a very, very useful tool. If you are working with data or if you're a data scientist, it's really a good skill to learn and to master. So, how do I master Pandas? I would highly recommend you follow my friend James Powell. He is a very powerful Panda user. He always gives out some tips in his talk and such. So you can follow him and then maybe look up some of his previous talks. That's very, very interesting and useful. Find your way of doing things, trying to be consistent, especially in the same project. Don't try to use different way of doing the same thing. It will be very, very confusing. But if you see some other people doing things different way, you can compare your way and their way and try to find the better one and stick with it. Try to adopt a better method if you could. The reason why I'm saying it is that, because sometimes you may not think of it, and then there's another way that may provide a better performance or a cleaner code, then you can adopt that way and, take it as your own. So the other thing is to try to understand the very complicated nature of Pandas. What is the series? What is the data frame? A very good way of understanding it is to contribute to Pandas. I would highly recommend, if you got a chance, there's a sprint, go to the sprint, learn from other people, learn from the maintainer. So there will be a conference coming up that you may get a chance to meet other Pandas user or maybe Pandas maintainers as well. That's EuroSciPy, is in August, it's in Basel, Switzerland. The details will be on the website, so if you're interested, please have a look and I may see you there. Bye!